Hello students, how are you all? So today we will learn about critical angle and total internal reflection. What is that? Always we have discussed about when light coming from rarer to denser medium, that is from air to glass medium. Then what happened? That due to variation of speed of light, the light bends a little bit. That is what the deviation called. And due to that, the phenomena or the property we called as refraction. Okay, so we know that idea, we discussed it many times in our previous videos. Right now, we will flip it up. That means the first medium I'm going to take as the denser and the second medium I'm going to take as rarer. So see some spatial phenomenon we will observe. In our last classes, I told you whenever this kind of situation will happen, the light will bend away from the normal. When light passing from denser to rarer medium, the light will bend away from the normal. That is what happening. No issue with that. But if you increase the incidental angle more, see the light is actually moving more away from the noise. That's what it should be. Okay, let increase it more, and I'm finally increasing. As you can see, light totally bent away. So मैं यहाँ पर रुकने वाला नहीं हूँ. I'm also increasing it, and in a such portion you will see that finally the light will come at very here. So that is called critical angle. So this part is called actually critical angle, where the light passing from here. So in this time, this is incidental angle I and this is refractive angle R. And as you can see, this refractive angle is nothing but 90 degree, right? So you got refractive angle as 90 degree. Acha, we know about the Snell's law. What does it explain? Sin I by sin R as equal to mu. Mu is what? That is the refractive index. So, in here, sin I by sin R, and I'm writing as mu 2 by mu 1 as I told you in our last videos. What is mu 2? Mu 2 is the refractive index of the second medium, and mu 1 is the refractive index of the first medium. Okay, no issue with that. Acha. So right now I'm marking this I as IC, that is called critical angle. The statement of critical angle is that when the incidental angle is critical, or when the light incident on critical angle, then the refractive light having refractive angle or transmitting angle 90 degree, or you can say the refractive angle will be perpendicular to the normal. That is, choice is up to you. Okay, so in the place of sin I, I'm writing sin IC. IC, okay. And sin R, I can put the value of R as 90 degree. Alright, no issue with that. So it is 90 degree. Now what is the sin 90 value? Sin 90 value is 1. So only in the left hand side we remained with sin IC. And in right hand side what you have? Mu 2. Right now see that mu 2 is air. So what should be its value? Its value is 1. Okay, I'm putting 1 in the place of mu 2. And mu 1, it is glass, 1.5. So you can put the value, but I'm taking mu, only mu, because maybe it can be water, maybe it can be glass or any other kind of custom materials. So I'm not going to any kind of discussion. I'm taking mu. Whatever will be the denser medium, you have to put the value according to their refractive index. So all you have this formula, very important formula over here, that is sin IC is equal to 1 by 1 by refractive index. So this is the formula for critical angle. Now coming to total internal reflection, that is what happening over here in this picture right now. Let me erase all this thing first. Okay. So all we have right now, first of all, what I told you, whenever light will fall like this in critical angle, theta c or IC, whatever you can write, then the refractive light will totally perpendicular to the north. So this is your angle. That is what happened when theta c or critical angle occurs. Now see that. Before critical angle, the light is pretty much showing the refraction. But after getting the critical angle, while you increase it more, that means more angle from the critical angle, the all light are getting bounced back. That is total reflection is happening. So this is called total internal reflection. I can show you the intensity of light. This is 100% the incoming one, and this is also the 100% for the outgoing one. That means all the light is passing by reflection. So also in refraction, the reflection is possible due to when the light moving from denser to rarer medium, and the more angle of incidental angle is more than critical angle. Just remember like that. Okay, so now what is happening? For more angle than critical angle, the light totally moving up and it is getting totally reflected. And we know for the reflection side, I is equal to R. That is incidental angle and reflected angle are equal with each other, and this is called total internal reflection. So today we have learned two things, that is total internal reflection and critical angle. I'm just recapping one more time, that is critical angle will give you the refracted light as in 90-degree refractive angle, and if you increase the incidental angle more, you will get total internal reflection. So what is the condition for total internal reflection? The incidental angle will be more from the critical angle. And one more formula we have learned today, that is sine theta c or IC equal to 1 by mu. So this is all about today's class. Thank you for watching. If you have any doubt, don't forget to write it in the comment section. Thank you.